All right, here we go. I wish they would just cancel school for juniors on this week. You almost don't give a crap about anything.
That's true.
All right, if I had NaOH and it dissociated, what would be the two things on the top? Tell your partner, not me. Na plus, good. And OH minus, what would be on the bottom? It'd be NaOH. All right, but you're basically going, no pun intended, where I want you to go. It's completely dissociated, right? So this is pretty much zero. So math teacher, what do we do when we divide by zero? The world explodes. Nothing actually happens. Like this is a undefined. So we never have the KB for a strong base because it completely dissociates. All right. So that's for a strong base. A weak base, we've said this before, a weak base would be like beryllium hydroxide. It is a base. It has the metal and the hydroxide, and it does not dissociate completely. What's that? Yep, it's one. Oh, you're right. It is two. So I need one that's just one right now. But there isn't one. We'll just say X. Thank you for that. All right. Now, that's important. Thank you for pointing that out. Or we would have had to have an exponent, right? Okay. So when we have the KB for a week, these two numbers, oh man, I'm so bad with my fingers here. These two numbers will be the same. That just annoys me. It just makes too much noise. All right, these are the same. Remember that? Because they dissociate in a 1-to-1 ratio. So just like acids, what does this really become? I'm going to write over here. The KB for a weak base will be equal to X squared over the initial concentration. They're the same because XOH decomposes into 1X and 1OH. So their concentrations will be equal because they separate in a 1-to-1 ratio. Yep. Okay, now, why is it initial? Well, remember, since it's weak, it dissociates to a very small amount, like 1 times 10 to the negative 6 or something like that. So if this number is 0.2, and you're going to subtract the amount that it dissociates minus 0.12345 it's basically 0.2. No pun intended again. So we're saying if it's weak, very little of it dissociates from its initial concentration. Basically, it's not that hard. All right. All right, my friends, here we go. So it's time to do math. So we've talked about this. I just did it for bases. We're going to do it for acids, and I already did it for acids. So we're really good. For a generalized acid dissociation, the equilibrium expression would be Ka. Remember, that's the acid. That's the A. Is H3O, which I'm lazy, so I call it H plus. It's the same thing. H3O is H2O with an extra H plus. So most of the time, a chemist will write H3O as just H plus. Okay, so it decomposes into its H plus and it's an ion. That's what A minus means. And this is how you'll see it. When you go to college, you will see it this way 100% of the time. Ka equals H plus times A minus over HA. The A simply means an ion. It's hydrogen's partner. Now, we said this before, as long as it's monoprotic, do you remember what that means? It's been a weekend. All right, good. It means as long as it's HCl and not H2SO4. As long as there's one proton, then these are always the same number. And our general equilibrium expression, or Ka for an acid, is always equal to x squared over initial. This is the proton. And yes, chlorine has its protons inside of it, but it's not really involved in anything at all. Because remember, an acid is donating a proton. Chlorine's protons are in and have nothing to do with anything. Okay, what we discussed this last week. It's been a while, but why do I have this little part right here? Well, tell your partners, why do I have that? What do pH and that X have to do with each other? They're like a terrible high school relationship.
Yeah, they're a very terrible high school relationship.
All right, so here's what happens. If this is equal to x squared, then x is really equal to H plus. Is it not? All right, well, and not just H plus, the concentration of H plus. Fair enough. Now, what if I did this? Could you find the relationship between there? We better, or you're in trouble on the exam. Oh, there you go. pH is equal to the negative log of H plus concentration. So how could we find this if we had pH? Okay, good. H plus concentration is equal to the inverse log, which is 10 raised to the negative pH. So here's what's cool. With Ka, I can find Ka, I can find H plus, I can find pH. I could also find POH, or the OH concentration. I need one single value and I can find all of them. Mr. Judah. Well, you always call me sir. Yes, sir.
So the negative pH, why does it have to be negative?
Why does it have to be negative? Because I want my concentration to equal a positive value. But really, and we got a math teacher in the room, so I got to be really careful here. The concentration is always like a number 1 times 10 to the negative something, right? But my pH, I always want to be positive. So to make it, and it doesn't have to be, besides I want it to be a positive value, to do that, because log, and correct me, I can't remember your name. Mrs. Noise, correct me if I'm wrong. Well, don't make me look stupid though. Deal? Okay, all that log tells me is the exponent 10 is raised to. Unless there's a number right here, but if it just says log, it means log base 10. So what log is finding is what 10 is raised to. So that means pH would be equal to -3, but I don't like it negative. So I take the negative log of it just to make it a positive value. So when we go the other direction, we will have that negative exponent. Well, we'll have a positive thing, but I need a negative exponent. No, it's all a decimal. So it's, I don't need that, I'm stupid. It's like point something, 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 something. And they relate to that. Did I say any false math doctrine? Okay. I was actually really stressed right there. Two things. You don't want to look dumb in front of a math teacher, and you don't want to suck in front of a student teacher. Okay, did that answer your question, Judah? Okay, so this is what I like about this. I know I'm a nerd, but everything can be found as long as you have one single value. Okay, so here we go. Yes. Yeah, and you gotta know the constants. Okay, so this is a nugget we should know. You don't need to memorize these. You'd be given a table, but it says the greater the value of Ka, the stronger the acid. Which should hopefully, now, I could actually, the test, that question didn't go super well. But a large Ka or Kb or Kc or Kp, any of them, if it's large, it is product dominant. Product dominant, which means it's dissociated, right? So if we have a large Ka, we are a stronger acid. Now, by the way, gotta be careful. Does it say a strong acid? No, these are weak, but we can compare weaks to each other and say one is stronger than the other. Yeah, in chapter 2, they're the bases in family 1, and then the calcium, strontium, barium. Those are the 6 or 7 of them. Okay, now there's nothing on this chart you need to know, but you should be able to answer a question that says, why did I do that? Let's say, based on the Ka, which is a stronger acid, acetic or nitrous? And I know that's super blurry. This says 10 to the negative 4. This says 10 to the negative 5. So tell your partner which one's stronger. Whoa, we have some juniors in this room. Well, have a seat. You're in the class.
Hey guys, we just have some papers for you guys to write a letter to your future graduated self. Turn it in to the office by Friday if you'd like it back. If not, I can tell you.
But we would like to. All right. Reese, don't make her feel bad. Okay. You're welcome. Now you can write this letter to yourself another time.
Did you guys get some papers?
It's good.
Thank you so much. You're so welcome.
Hey, you're welcome. Good to see you, Parky. Okay, so back to me, please. Back to me, please. Ian got it right. What a guess. Why 10 to the negative 4? Because it's a bigger number. Now, don't be that kid that thinks a 5 is bigger than a 4. It happens. 10 to the negative 4 is 0.1, 2, 3, 4. 1, 2, 3. Well, I know, but trust me, I've graded AP tests for a long time. And you think about concepts in such a difficult way, you lose track of things that are easy. No, we're not picking on anyone right now. Here we go. Here we go. I get it. The pH of a 0.1 molar solution of formic acid at that is 2.38. Calculate Ka for the formic acid at this temperature. Finally, we get to do some math. What's that?
Formic acid. Does that make a difference?
No. Yep, this is just the name of it.
What is a formic acid?
Formic acid is HCOOH. That's the name of the acid. It's from the formate ion. Yes, sir. I did. Okay, now moving on. So how do we go about this?
You just set up the ice table.
Okay.
Use the exact same thing.
It is similar, but is it exactly the same? No. Here we go. So the reaction is HCOOH goes to H plus and COO minus.
It's only goes to, right? It's not calculated.
Well, no, this is an equilibrium, or we wouldn't be calculating Ka.
How is COO possible?
It's a polyatomic ion. And that goes way, way back 12 chapters. So I'm going to skip on that.
That's like half my name.
Yeah, it is. Okay. Does it give me an initial concentration of any of them?
No. Well, actually, formic acid.
All right. It gives me that. 0.1. All right. 0, 0. All right. It tells me the pH is 2.38. What does that tell me? All right. So good. pH is this. So my H plus concentration is equal to 10 raised to the negative 2.38. Someone calculate for me. Okay, I'm gonna write that right here. What is it? 0.00417. Okay, that tells me a couple other things. This is an ice table. So it means that this increased what?
0.00417.
Okay, so these are pluses. Reactants decrease. So someone do that math for me. It's 0.09. Oh, that's 0.1. I'm an idiot. I didn't notice the point there. 0.09 what? 983, right? Oh my gosh, I can't. Okay, my bad. Okay. Now what do we do? Let's just plug it in. So Ka is equal to 0.00417. There's a 1 there, my fault. And yeah, let's just save me some finger ink and just square it over. Yeah. You know how hard it is for me to do this every day? Yep. You think it just comes from nowhere? The Diet Mountain Dew is fueling that. Yeah. Okay. What do we get here? Okay, hold on. Nisha or who? Caitlin, speak.
1.8 times 10 to the
It's okay. We could look. Yeah, there's 2 sig figs right here. Do they do that in math ever? Sig figs anymore? This noise? Oh, wow. You changed your name. Oh, that was rude. Sorry. All right, 1.8 times 10 to the negative 4. That's the Ka. All right, so we can do it with an ice table. Someone do me a favor. The favor is calculate this 0.00417 squared over 0.1. Tell me what that equals. Did you already do it? 1.74 times 10 to the negative 4. Okay, that's a little farther off than I thought it would be. But what's the second one I asked you to calculate? It's the x squared over the initial. Which, wow, random smiley face right there. Yeah, my sleeve did that for you. Which generally speaking is good enough. Generally speaking. Now, this one borderline, whether they would or not, here's the deal. If you are off more than 1%, they'll usually care. But they usually give you a larger value here. So if this was, 0.5, 0.6, it makes it even less and less of a difference. So I would not spend your time on a weak acid or base doing an ice table. I would take my pH, use it to find my H plus, or square that number and divide it by my initial, and we're ready to go. We were 6/600ths off of being in the 10,000th place, right? So we're not super far off, but we were kind of off. Okay. I don't think they would have. Hydrofluoric acid dissociates in water as represented by the equation above. Now this one's different because this one gives you the Ka. All right, write the equilibrium constant expression for the dissociation of HF in water. Can I remind you of something I didn't even grade on your test? This could have said, write the mass action expression. Oh, right, it's just that. The mass action expression just means it's written out without any numbers. Okay, look at this real quick right here. This has like a giant red flag in it that tells you you're going to get wrong. It's the water. Good job. This is not part of the mass action expression. Tell your partner why. Because it's a liquid. Good. So I have H plus. Are we comfortable that this is the same? Okay, if you're not, transfer out. All right, because I'm too lazy. And we have F minus, and that would be over HF. Yep, your F minus. Okay, calculate the molar concentration of H3O plus in a 0.4 molar solution. Okay, so we know that Ka equals this, right? So let's just put it together. It's just math. Ka is 7.2 times 10 to the negative 4. And we know it's equal to what? X squared over the initial, which it gave me. I scrolled, I guess. No, I didn't. Where is it? Oh, it's right here. I was looking up here to find it. It's right there. 0.4. So pretty easy. Multiply both sides by 0.4. Cancel those out. Take the square root of whatever that was. This is the worst square root ever written by a human being. Oh, okay. You get the idea. So take the square root of 0.4 times 7.2 times 10 to the negative 4. Nisha, you got me a number?
Yeah, I got 0.01.
Could I get a second one? All right, good. And that's equal to the what? Concentration of H plus. Now it could be F minus, but do I care for this question? No, I need H plus. Okay, so now the last step is to find pH. pH is equal to what sign, Judah? Negative. All right, the negative log of the H plus, which is 0.017. Nisha, you type that in yet?
Yeah, it's 1.7.
So we say 10 raised to the negative 0.017.
No. Would this pierce? No. That one, no. But we've reversed math now. So instead, we don't need to solve for H plus given pH. We're solving for pH given H plus. So we go, we push the negative sign on your calculator, then the log button and 0.017. You type it in and hit enter. It's 0.4. It's not there. It was under the square root sign. There was a little dot. I apologize. There's a little decimal. It was right here before, but then I ruined it with my square root. Yes, it was high quality. And that's why I would never be hired as a math teacher. But, and math killed me. So how do we feel about that? Kind of cool. Like, I don't know, maybe I'm weird, but this floats my chemistry boat. It puts Soraya to sleep, but that's normal. It's daylight savings time. I understand. You should be at lunch right now. All right. Are we ready for another practice? Good answer. Okay, fire away. The pH of a 0.1 is that. Calculate Ka. Is it the same one? Okay, well, I can change it.
Do you want us to do the full entire ice table as practice?
No, don't ever do another ice table again on these. Okay, now I'm saying the pH is 4.5 because I feel like it. Now calculate. This is a chapter where I can just make up quick practice problems, unlike some of those last few chapters. Oh, that would be another struggle of math, is just making up an example that works like you want it to. I don't envy that. Garrett, is this stuff making sense to you? No, he has himself muted. He's sleeping. All right, when you're done, raise your hand. Check with your partner, make sure you match. All right, so we had Ka equals x squared over 0.1. We used the 10 raised to the negative 4.5 to find out what x was equal to, and it was equal to some.
It was equal to 0.000031 so 40.
Okay, and I'm going to square that number, right?
Yeah.
And then divide it by 0.1, and that equals what value? 1 times 10 to the negative 8. Just straight up 1 times 10 to the negative 8. Wow. I guess that makes sense because you square 3 point. Okay, that rounds to around 10. I don't know. I was very distrusting of that answer. Sorry, Nisha. Usually I have way more faith. It's just too clean. That's too clean. Isn't that too clean? You're like, there's no way. Because if it's 1 times 10 to the negative 8, that means your answer is 0.00 whatever 1. And that's like going to Walmart and they're like, all right, it's $45. You're like, no, it is not. I've shopped a lot. I've been here before. Okay, well, answers. What time are we out of here? You can do part A. There you go, Nisha. Let me try that again. Oh, that was hacky sack. It's supposed to go that way. All right, we can do this so fast. We can do it. Like Noise just did it in her head, I guarantee you. I had a kid, I've complained about him before. He wanted to prove that he was a genius, so he wanted to do the AP test without a calculator.
Did he do good or not?
No, I got a 1.
You got a what?
How do you do logs without a calculator? I don't have a choice.
But I'm just saying, like, he was actually like probably one of the biggest idiots you ever taught.
His last name was Rasmussen.
It was Rasmussen.
It was a Rasmussen. That doesn't mean anything.
Is he related to Rasmussen?
Yes, it was his child.
It was Rasmussen's son. Wasn't Rasmussen actually really smart?
He's a genius. Did I set that up right? What'd you get?
Final answer was 2.52 times 10 to the negative.
I think Rasmussen got a
Wait,
35.
say that again. I'm deaf.
2.52 times 10 to the negative 6.
Yes.
All right, we'll work on part B. You guys are great. I haven't offended anyone in this video, so I believe I can upload this one to the internet. Well, there's nothing wrong with that.